Hello student, welcome to digital classes. This video is for class 9. This is the continue or a second part of the chapter number 2 is matter around us pure. We already discussed about pure substance, element, compound, impure substance, mixture, elements, classification, physical property of metal and non-metal, like mixture, heterogeneous, homogeneous, and the properties of mixture, compound, physical and chemical changes, etc. Now in this video I am going to tell you about separating the component of mixture with the help of evaporation, centrifugation, frictional distillation, chromatography, distillation, and then application of distillation, and so on. Now I start separating the component of mixture. First, how can we obtain color component dye from the black or blue ink? This is done by the evaporation. Process of evaporation is used to obtain colored component from blue blank ink. The process of evaporation is used to separate a substance which is dissolved in water. It is based on the fact that liquid vaporize easily than the solid. Helps in separating volatile substance from the non-volatile substance. We use evaporation. Now in this process, put a few drop of blue ink on a watch glass and place it on a beaker half full with water as shown in figure. The water is in the beaker is heated and the steam thus formed will in turn heat up the ink. The water present in the ink will evaporate and ultimately a blue residue will be left on the watch glass. It may be noted that the direct heating of ink is avoided because of the blue or black dyes may decompose on direct heating. See in the figure. This method can be used to separate non-volatile component solute dissolved in the volatile solvent. For example, this technique is used on a commercial scale to obtain common salt from the sea, water or lake containing common salt. Sea water is collected in open swallow beds during high tides and allowed to evaporate in hot sun. The salt left behind is collected purification in the factories and sold in the market. Now the separation of cream from milk. The process of centrifugation is used to separate the cream from milk. It is a method of separating the suspended particle of a substance from a liquid. This process is carried out by the machine called centrifuge. Sometimes the solid particles in a liquid are very small and passes through a filter paper. For such practice, the filtration technique cannot be used. For example, when milk is rotated at a high speed in a centrifugation machine, the lighter fat particles collide with each other to form cream which stay on the surface while heavier particles of the milk are forced to come to the bottom. As a result, separation occur and the cream is collected from the outside provided near to the top of centrifugation machine while the milk is collected through an outlet provided near the bottom of the machine. By using this technique of centrifugation, different varieties of milk containing different amount of cream such as full cream, toned, double toned varieties of milk are prepared. These are packed in a polypack or tetra pack and then sold in the market. Now the application of the centrifugation. The technique of centrifugation is used in the diagnostic laboratories for blood and urine test. It is used in dairies and homes to separate butter from cream. Centrifugation technique is also used in washing machine to squeeze out water from the wet cloth. It is used in laboratories and industries for separating suspended impurities from the liquid. Separating two immiscible liquid. The separation of separating two immiscible liquid is carried out by the use of funnel. The basic principle involved is the difference between the density of two liquid from two separate layers. Now, kerosene oil and water do not mix. When these liquid are mixed, they are formed two separate layer. Such pair of liquid which do not mix with each other are called immiscible. The liquid forms heterogeneous mixture. The individual component of such heterogeneous mixture can be separated by using a separating funnel. Steps of separating kerosene oil and water. Pour the mixture of kerosene oil and water in a separating funnel. Let it stand undisturbed for some time so that separate layer of oil and water are formed. Open the stop cock of the separating funnel and pour out the lower level of water carefully. Close the stop cock of the separating funnel as the oil reaches the stop check. By using separating funnel, kerosene oil being lighter than water forms the upper layer while water being heavier form the lower layer. The boundary of the separation of two liquid is clearly visible. Now place a beaker below the funnel and open the stop cock and allow the water to fall in the beaker, and you may close the stop cock when the oil level is near the stop cock. Now the application of funnel or the application of solvent extraction. The technique is used to separate a mixture of oil and water or mixture of any two immiscible liquid like benzene and water, chloroform and water, ether and water, carbon tetrachloride and water, etc. To extract organic compound present in the aqueous solution using a water immiscible organic solvent like chloroform, benzene, ether, carbon tetrachloride, petroleum ether, etc. In the blast furnace during extraction of iron, two separate layers are formed. The upper layer contains of the molten sludge, calcium silicate, while the lower label contain of molten iron. The lighter sludge is removed from the upper hole while the molten iron is removed from the bottom hole of the furnace. Now the sublimation. This process is used to separate mixture that contain a sublimate volatile component from a non-sublimable impurities. Sublimation is a process where a substance directly change from solid to gaseous state on heating. We have already studied in chapter 1 that on heating ammonium chloride undergoes sublime or sublimation, that is it changes directly from solid to gaseous state without passing through the intermediate liquid state and vice versa on cooling. Some example of substance which undergoes sublimation are ammonium chloride, camphor, naphthalene, anthracene, benzoic acid, iodine, etc. Thus, the process of sublimation can be used to separate sublimable volatile component from the non-volatile component of mixture. A mixture consisting of ammonium chloride and common salt in taken in a china dish and is covered with a perforated filter paper. And inverted funnel is then placed on the china dish and its stem is closed with a cotton plug. The dish is heated gently when the volatile substance, that is ammonium chloride, change into vapor. The vapor pass through the perforation of the filter paper and get deposited on the inner surface of the funnel. This is known as sublimate. The non-volatile component of mixture, that is common salt, remain in the china dish as residue. The sublimate the sublimate, that is pure ammonium chloride, is scraped from the funnel with the help of a spatula. Now, chromatography. This method is used for separating colored component from a liquid by using a filter paper or blotting paper. Chromatography is the most modern and versatile method used for the separation, purification and testing of purity of inorganic and organic compound. This method was first discovered by Swart, a Russian botanist, in 1906. This technique was first used for separation of colored substance, plant pigment, and hence the name chromatography was given. Chroma is a Greek means color and graphy means writing. However, now this method is widely used for separation, purification, identification, characterization of both colorless and colored component of a mixture. Type of chromatography. With the advancement in technology, many type of chromatography such as column chromatography, thin layer chromatography, gas liquid chromatography, high performance liquid chromatography, etc. have been developed. Put the simplest form of chromatography is the paper chromatography. Therefore, we will discuss paper chromatography here, while other type of chromatographies you will learn in a higher classes. Usually the ink that we use in a solution of two or more different colored dye in water. With the help of paper chromatography, we can easily identify the different color dyes present in ink. Theory. We know that one or more different substances may be soluble in the same solvent, but their solubility are usually different. Thus, when a solvent, say water, is allowed to pass over a mixture of such substance, the substance which is more soluble in the solvent move faster and thus get separated from the other substance in the mixture which more slowly. Thus, separation identification of different component of a mixture by paper chromatography is based upon their solubility in the same solvent. Let us discuss the separation of dyes in black ink using chromatography. Procedure. To carry out the experiment, take a thin strip of special type of filter paper called the chromatography filter paper. Using a pencil, draw a dot line across width of the filter paper at about 3 cm from the bottom. Put a small drop of ink from a sketch pen or a fountain pen at the center of this line and let it dry. Suspended the paper in the glass jar containing water so that the spot of the ink on the paper is just above the water level. You will see in the figure also. As water rise up the paper by capillary action and flows over the spot, it takes along with its dye particles. Usually ink is a mixture of two or more colored dye. The colored component which is more soluble in water rise faster and produces a color spot on the paper at a higher portion. The less soluble component rise slower and produce colored spot at the lower height. In this way, all dyes present in the black ink get separated. When the water reaches near the top end of the filter paper strip, the paper strip is removed from jar and dried. This paper with colored spot at different height is called chromatogram. Now the chromatography used to separate those solute which dissolve in the same solvent, used for separation of color. The color which are more soluble in water rise faster and get separate into the layers. Now this is done in the activity which I told you just. Now the application of chromatography to separate colors in a dye, pigments from the natural color, drugs from the bloods. Students who are interested in cricket are, I think, know about dropsy. in which the drugs found in a player's body detected by this application only. Distillation, used for separation of component of a mixture containing two miscible liquid that boil without decomposition and have sufficient difference in their boiling points. Basically, distillation is used to separate the component of mixture containing two miscible liquid, means the liquid which are able to mix with each other. The principle for this process is the separation is based upon the principle that at the boiling point of the more volatile yani low boiling point liquid of the mixture, the vapor almost exclusively consists of more volatile liquid. Likewise, at the BP yani boiling point of the less volatile high volatile liquid, vapor almost entirely consists of less volatile liquid, since the more volatile liquid has already distilled over. Thus, the separation of the liquid mixture into individual component can be achieved at their respective boiling point. The more volatile component distills over fast or first, while the less volatile component distilled over afterward. Now the frictional distillation. Frictional distillation is used to separate a mixture of two or more miscible liquid for with the difference in a boiling point is less than 25 K. Air is a homogeneous mixture and can be separated into its component by frictional distillation. For separating the component of air, first air is compressed by increasing the pressure and then cooled by decreasing the temperature. Under this condition, carbon dioxide of the air get converted into dry ice, which is separated while the remaining gas of the air get condensed to form liquid air. The liquid air is then subject to frictional distillation or allowed to warm up slowly in a frictional distillation column. When gases get separated according to their boiling point, the gas with the lower boiling point get distilled first. Since the boiling point of nitrogen 78% of the air by volume is the lowest, that is minus 196 degrees Celsius or 77 K. Therefore, it get distilled first of all, followed by argon with boiling point of minus 186 degrees Celsius or 87 K, while oxygen has the highest boiling point, that is minus 183 degrees Celsius or 90 K. Therefore, it get distilled last of all. The application of the frictional distillation. The process of frictional distillation has been used to separate crude oil in the petroleum industry into various useful fractions such as gasoline, kerosene, diesel oil, lubricating oil, etc. Frictional distillation of a liquid air is used to separate gas of the air. The frictional distillation has been used to separate a mixture of acetone. The boiling point of acetone is 329 K and the methyl alcohol and their boiling point is 338 K from pyroligneous acid obtained by destructive distillation of wood. Now the limitation of destructive distillation. The component of content boiling mixture are azeotrophs cannot be separated by the frictional distillation. For example, rectified spirit consists of 95% alcohol and the boiling point of alcohol is 78 degrees Celsius and 5% water. Its component cannot be separated by frictional distillation because they form a constant boiling mixture. Azeotrophs, even through their boiling point, differ by 22 degrees Celsius. Crystallization, used to remove impurities from solid and purify it. It separates a pure solid from mixture in the form of crystals. This process is used in purification of salt from the seawater, separation of crystal of alum from the impure samples. It is better method than evaporation, means the crystallization is better method than evaporation because the solid decompose or some like sugar may get charred on heating to dryness. Some impurities may remain dissolved in the solution even after filtration. On evaporation, these contaminate the solids. This is the apparatus actually used for separation of gases. I think everyone would understand whatever I taught in this video. If there is any problem or you find any problem, you may discuss within the class in the science period.